So now, here we have a circuit. We have a couple green LEDs right there. Lamp was not at its brightest setting. It's kind of dim. You may be able to tell. They're glowing a little bit right there. But we really don't have enough supply voltage to light them. We got 5 volts, and we will get burst of short burst of relatively high current. But in any case, we got 5 volts right there. We really need about 6 volts to get them to light up quite a bit. In fact, let's change that to 6 volts. And you can see already it's doing much better right there. We'll drop this back down to 5 volts. So that's what the rest of the circuitry is for. It's called a voltage doubler. You don't actually get twice the voltage. We will never get 10 volts across here because we have a couple of diode drops. But we get close to twice as much voltage. I just got to press this once and we get burst. So if I go rapidly enough, then we'll get quite a bit more than 5 volts, although this load will keep it down a little bit. So now we'll do a step-by-step build right here. So first off, we got to the positive supply one side of the switch. So it has 4 terminals right there. The top 2 are always connected together. The bottom 2 are always connected together. You can see there's a little gap running down the middle right there, and it fits on the breadboard that way right there pretty well. They're spaced to jump the gap right there. Now they also go up and down a little bit right there, the wide part right there. So you can take a pliers and turn them and whatnot so that they line up better with the clip in the breadboard. I have never done that so far, but these do pop out, especially when I first inserted it in there. Now it's kind of made the spots conform a little bit. Be aware of that. So, in any case, we start with that. Now, we're going to have a pull-down resistor connected to the negative side of the capacitor. These are polarized capacitors. You got to put them in the right way. So, 220 ohm resistor. Exact value doesn't matter. Just remember, when you close the switch, that does give an instant charge to the capacitor towards the negative side, but this side gets charged more positive, so that's okay. It will just, in a way, just push more charge through the capacitor. It will not reverse charge it. So we got 220 ohm resistor going to the negative supply, so I'll add that right there. Make sure it's going to the negative supply. Now it's going to the negative side of the capacitor. That's what that is right there, that little cup there. You may or may not see a plus next to the bar there, but the bar is the more positive side. So very easy to tell where the negative side is right there. 1000 microfarad. We could charge this up to 35 volts right there. So we could add another stage to this and get an even higher voltage. But I'm going to put it down in the middle spot right there. I think will work best. And now we need to add a diode. So the diode, it's going to be this one over here, even though it's off to the left on the board. And I removed the power supply. I also turned it off. We have a rectifier diode right there. So again, it's coming from the positive supply, and there's a gray band right there. That's the negative side. That's the cathode of the diode. I shouldn't say negative side, it's the cathode. Over there is the anode. That side has to be more positive, that side more negative, in order for positive and negative current to flow through it. We're going to talk about conventional current right now. Of course, electrons go in the opposite direction in reality, but there's a system of conventional current going positive and negative that they came up with before they learned about electrons. So there you can see that charge path right there. Normally it charges, that side gets more positive, that side gets more negative. When we close the switch, now we got positive, and then when it heads towards negative, those voltages add up like series batteries, basically, until the capacitor discharges. Then current stops flowing, and so their voltages add up, but when this gets down to 0 volts right there, then there's no voltage difference, and we got higher than 5 volts over there, so it doesn't reverse charge. So now we got the other diode that we're going to use. So this is going to isolate this whole part of the circuit and this part right there. They're going to be separate other than when we pump charge in. It'll keep charge from going back. And then same thing with the diode right there. If you charge up the capacitor, close the switch, without that diode it would just discharge instead of pumping the charge that way. So we're going to add it again. Cathode right there, the gray band. headed towards our load, anode headed to the positive side of the capacitor, even though it is wired up differently than the schematic. Doesn't matter as long as the connections are the same. So doesn't matter the layout. It's wherever the connections are. So yeah, now we can get our charged pump this way, and also we'll start off with the 1000 microfarad capacitor. It will also give a slight charge to the capacitor. It's probably stored a charge, but you'll get a lower charge right there. That helps to prevent that from getting reverse charged later on. So in any case, again, negative side right there, band, 1000 microfarad, 35 volts. The value of the capacitors don't matter at all. Just the larger they are, the more charge they're going to store. That's all that matters. So we don't have to do this process as quickly the larger value capacitors that we got. Now, we're going to protect the two green LEDs that are in series. They're going to build up about 6 volts total, 3 volts each, while they're conducting. So we need to exceed that to really conduct. So I already got the gray jumper there to the negative supply. So the resistor I want to put to the, this is 1000 ohm resistor, to the positive side of the capacitor. I'm going to make sure I got that lined up properly first, and then I'm going to go over a spot right there. And then up, we should be up a couple spots from the gray jumper, and we are. 1, 2, right there. And we got the green LEDs. So that's the long lead, the anode, short lead, the cathode. So shorter lead, and there should be a flat edge on the cathode side. I'm pretty sure right there. And so yeah, we'll plug that in. I'll do this quick again. And long lead towards more positive, short lead towards more negative when it is powered. And we got a little bit of glow right there. That is the capacitor, because the power supply is not attached right now. So it's keeping current trickling through a little bit right there. I'll make the lamp brighter. So I did not turn the power supply off, but I did disconnect it. So I tried to do both. It's a good idea to do both. But in any case, we will attach this now. And we wired it up. Pretty sure everything is wired correctly. We still got that faint glow. And if I press the button, there we go. We got the bright flash. So again, when we got some charge at that capacitor, and then some charge at that capacitor. This one is mostly charged, 1 diode drop less, and then this one will get down to 2 diodes less than 5 volts right there. Each one of these diodes probably drops about 0.6 volts at this low current right there. And then this one now discharge, it's trickling through right now, but we can measure the voltages later. But just one press of the button, that brings the power supply in series with this capacitor right there. You can see it pushes in that direction, pumps charge into that capacitor, and it trickles through the LEDs. Of course, we don't need the LEDs. They're not going to be as bright right now, but the pump will just provide a flash, which, that's actually a pretty cool looking flash, however fast you want to make it. If you just want to make a real brief flash, that's a pretty cool effect as well. Now, again, you would not use, a switch like this in a practical circuit right there. There's other types of switches. The 555 timer is a common switch to use when you want a repeated. It gives you a high-low, but basically it connects to the positive supply and then disconnects and so on. Or you could wire it to where the charge pump works with a negative supply on that end. You'd have to rewire everything the opposite way, but it is possible to do. So now I got the multimeter here. It's safe to measure voltage. This meter, all I have to do is set it to V. It does the rest. Only time I have to move a probe is if I move the red probe to 10 amps for measuring high current, above, I believe, 0.6 amps of current. Anything higher than that, I want to move the red probe. But we're just going to measure voltage here, pretty straightforward. It can either be set for AC or DC. It needs to be DC. This is a DC circuit. And I have these alligator clips, which I store that way, clip to a voltage regulator, which I also twisted the pins, or I did twist the pin sideways so they fit in the board better right there. But in any case, it's an alligator clip. Both ends of the wire look like this. I just clamped with a pair of pliers the metal part of the alligator clip connection to that pin, and it makes a pretty good connection in my opinion right there. So that's going to go to the negative supply. This is 0 volts ground right there. And now we're going to grab the positive, and I do have the board powered, as you can see right there. And first we will look at that. So as I said before, this is considered 0 volts negative supply. I'm also going to put the red one to the negative supply right there, and you can see 0 right there. So there's 0 volt difference between the two. That's what it's saying. And over here, again, I set the power supply to 5 volts. It may not be a perfect 5 volts, but more likely the resistance in the wire right there. It's giving us a little bit lower voltage. So you got to be aware of why you're getting all the readings that you're getting. So first off, as I said before, this capacitor is charging, but it's charged, but it charges through that diode right there, a rectifier diode. So when current's really flowing through it, it'll probably build up about 0.7 volts. Whatever follows it will have about 0.7 volts less. But current can trickle through and thus charge a capacitor to, higher than 4.3 volts. So looks like we're about 0.4 volts lower, but that's because no current's flowing. Now, when I press the button, you'll see that the voltage went up. It's going down now though, but I put the positive supply in series with the charge capacitor there headed to ground, and therefore it raised the voltage. The more I press it, the more it will rise, and then I got to hold it, to keep that voltage. When I release it, then the capacitor recharges, the voltage changes. But while it's in series with the power supply, you can see it went up. We can see like 6, 8 volts, whatever. Oscilloscope would give you a better reading, but we're going to keep this one simple. Now, that is pumping charge into that capacitor. So we should see a higher voltage most of the time right here. And it's more steady because it's holding charge. The capacitor is bringing it down. So yeah, it looks like we're getting pretty accurate view of this capacitor voltage right there. Again, the green LEDs above 6 volts are going to conduct, pretty freely. That 1000 ohm resistor is going to limit the current. So we probably got about 2 milliamps of current flowing through the green LEDs, which is perfectly fine. You can see they're really bright right there. 2 milliamps is fine. So it's okay to make a circuit like this if you really need, 2 series green LEDs for some reason, So any case, we'll get back to this. We will remove the load. So I'll just pluck the green LEDs. So of course, they're discharging that capacitor over time. So this is not a high current thing, although you can get fairly high currents if you go fast enough. Again, if you're using a timer to just keep charge pumping the capacitor there. So switch kind of came out. But yeah, we'll get, you can see as the voltage goes up, of course, it's not going to accept as much charge because this will have a higher voltage. These two voltages added up together are closer to that voltage because these don't get any higher over time, and therefore as they get closer, a little less current's going to flow through. But in any case, we can get it to level off. Looks like about 9 volts right there. So again, we got the 2 diode drops to deal with, and so that's about 9 right there. We should get about 9.5 here when I hold the switch once the capacitor's charged. And there you can see, yeah, it's about 9.5. So these are not exact numbers. I'm just kind of going based on what I saw from earlier, what we're losing through the diodes when there is very low current trickling through right there. It's about 0.7 volts at probably an amp, 0.6 volts, in the lower milliamp ranges and so on. And looks like you can probably get about 0.5 volts when current's just barely trickling through it right there. So something to be aware of when you are looking at forward voltages and how much it's dropping from circuits right there. You can't get an exact amount of voltage. Let's say you're charging a battery and you figure it's dropping 0.7 volts. So you put the power supply 0.7 volts higher than the maximum voltage of the battery. Current is going to trickle through when the battery gets close to the maximum voltage. So it'll go up a little bit more than you calculate if you go by that. So something to be aware of when you're dealing with diodes. But yeah, let's rewire this up to finish this off really quick right there. So that's really about it. And again, this is just a demonstration circuit, voltage boosters are really cheap right now, and they actually convert the voltage. And there's buck converters as well, boost converters and buck converters. They actually take the power that you got. This kind of does too, but we got the diode drops. But you know, you can get like 10 volts to a load, and if the load needs like 1 milliamp of current, this 5 volts has to provide 2 milliamps of current. So power stays the same. 5 volts, 2 milliamps in for 10 volts, 1 milliamp of current out for the load, although there are losses with those boards and stuff. So for these lower current circuits, so the board would use up current as well. So it wouldn't be as efficient as like a voltage doubler right here. So, you know, just something to be aware of. There's different uses for them. The main thing was that we looked at how this works. And I'll remove this. This went on long enough, but I'll wrap this up with a look at the schematic diagram again with the circuit. Thanks for watching. Make sure you check out one of the other videos I'm posted to the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.